Pollution that continues to explode poses severe threats to the health of our planet. Science has doubled the lifespan of humans and cured many diseases, brought us more food, better living conditions, and because of that, the world population has taken off and exploded. We look at where the population was more or less steady for thousands of years, in fact, millions of years, and then suddenly, with the Industrial Revolution, the application of science goes up in a curve. I've stopped this at the year 2000. All the numbers up to the year 2000 fit a mathematical formula which would predict that the population of the world in the year 2017 becomes infinite. This is more rapid than an exponential. Now, as you all know, when you find physics, if you calculate something like that, and you find that your equations give you infinity, something's wrong with your equations. And something, in fact, is bound to change. And in fact, demographers have already identified that this curve is turning over. And the population of the world, through education mostly, is stabilizing. But it's not stabilizing at the current 6 billion people we have, but at anywhere between 9 and 15 billion people. It's a lot of people for our small planet. And these people consume more and more energy and more things. The global energy consumption also took off with the Industrial Revolution and continues to rise in the same kind of way. And that's not just because of the the growth in population. This is also true when plotted per capita in the richest of countries. And that global use of energy is based on using up the scarce resources that have accumulated over hundreds of millions of years and lots of dead animals. All the fossil fuels and oil and coal and gas, which make up most of this energy consumption. Not only will we eventually run out of these fossil fuels, but this process of using up carbon-based animal remains emits CO2 into the atmosphere, which undeniably now we have evidence is causing a sharp increase in the temperature on the Earth. The following slides are taken from the IPCC committee that won the Nobel Prize this year for peace, for alerting the world to the dangers of global warming. This is their projections of the Arctic surface temperature over the next century. There's a whole range of projections here, anywhere from 2 degrees, if we really do something about the problem, to 8 degrees centigrade. This may not seem like a lot, but it is, as I will show you. And it is unquestionably now, to most of our satisfaction, linked to human activity, to the burning of fossil fuels, to the destruction of forests, to man-made activity, which produces CO2, and the CO2 that goes into the atmosphere is growing like this, tracking very well the rise in temperatures. Now these rises in temperatures of a few degrees over the next century might not seem like a lot, but it is a big deal. Already, we are all aware of the effects of global warming in many places, decreasing water availability, too much water in some places, too little in other places, big changes. But if, as we get to increase the temperature by 1 degree centigrade, which with a very conservative estimate will happen in the next decade or two, scientists estimate that 20 to 30% of known species will be driven extinct by the change in their habitat. Most coral reefs will be bleached white. And we will have continual heat waves, floods, and droughts that dwarf what we've experienced in recent years, leading to increased mortality. With an increase of 2%, 2 degrees, we will have major effects on natural systems and biodiversity, threats to many water and food supplies throughout the world, death of most corals, and millions of people will face flooding risks every year. With a 3-degree rise in temperature, there will be incredible burden on health services. Global food production will start decreasing, and about 30% of coastal wetlands will be lost. We have a 4-degree rise in temperature. More than 40% of known species will be driven extinct. The effect on global GDP just by that will be up to 5%. And there will be at least a partial meltdown of Greenland and the West Antarctic ice sheets, leading to increased sea level by 13 to 20 feet. That's just 4 degrees. Remember, in those projections, we're anywhere from 2 to 8 degrees. We already see the melting of the Greenland ice sheet and the bleaching of corals. So this is a severe problem that we all are becoming more and more aware of and need to take action. And science, of course, can and must help. We have technologies that can be used today, but even more promising are new technologies that we could develop. We have incredible advances in the control of individual atoms, so-called nanotechnology, that could lead to totally new ways, more efficient and less destructive. And we have the hope of realizing the untapped energy of the sun, which is renewable, sustainable, and totally clean. But more than science is needed. This is, in my opinion, primarily a challenge to the politicians and to religious leaders, to everyone. It's a social, political problem more than anything else. Partly it's just getting together and agreeing to function like a planet and solve this problem at some cost, but the cost is less if we do it now and not wait 10 years or 20 years. It would be much more expensive and disastrous then. But more than that, I believe, we must start thinking about how we function as economic and political entities. I believe that we must begin to think of building an economic and political system that is not dependent on unlimited consumption and growth. Now you might say this is easy for a rich country, a rich American to say, where the underdeveloped world, including the Philippines, needs growth. Take many of its citizens out of poverty, give them opportunities, and that's correct. So I'm really talking about my country, the developed world, where even there politicians don't dare to promise anything but unlimited growth. And when they talk about global warming, they say, we can lick the problem of global warming without threatening growth. If a politician doesn't succeed in having a growth of a few percent, economic growth of a few percent every year, they're voted out of office. If a CEO doesn't have a company that grows by a few percent or more every year, they're fired. Our whole economic and political system is based on growth. Well, I don't believe we can go on having such economic and political systems and the ensuing ever-increasing consumption of goods. It's not just the threats to the environment and global warming, it's the depletion of all resources that have accumulated on this earth over the millennia, over millions of years. We need a better system. And nobody's come up with a better systems. Systems that have tried in the past or have been different haven't succeeded, have failed. But this one will fail too, and we need some alternative just to have a society whose main goal, as taught by the media and the politicians and the leaders of business, growth, growth, growth. And finally, I think we're not going to solve this problem unless we have something which begins to approach world government. The threats that we face are threats to the world as a whole. And whatever we do in one country affects the whole world. And they're threats to our species. We're all one species with a common ancestor of 150,000 years ago. From that point of view, this division into nationalities and countries seems kind of silly. So I'd like to say a bit about internationalism. And here I think science is a good example because science is the most international of all activities. And that's partly because the problems that are explored by basic science are not posed by politicians or countries, but by nature itself. And nature has no boundaries. And in approaching scientific research, anyone's idea is reasonable, worth considering. No one is special, no country, no kind of person. All are equal in scientific research. So because of that, science from early on has been a truly international endeavor and in many ways a model of cooperation and collaboration with, of course, competition. Scientists are very competitive, one with another, one institution with another, but they come together and collaborate and cooperate in ways that transcend all boundaries. That's why scientists, someone like Albert Einstein, was a true believer in world government. And after World War II, with the threat of nuclear weapons, the destruction of mankind, he pushed very strongly for that. And in this letter that he wrote, he's very great. He writes that he's very grateful for this opportunity to send greetings to a gathering of persons devoted to the cause of world law. And as he says, the growing movement of a supernatural government seems to me today the major hope of mankind. Only world law can assure us progress towards civilization, peace, and true humanity. Now, the problem that he was most concerned with at that time, 1946, was atomic bombs, which luckily for 60 years we've avoided using. The threat is still there, but now we face other threats, perhaps even greater, to the health of our planet, which are truly worldwide and involve us all. And again, I believe that Einstein is right. And eventually this will happen. I'm going to end now with some questions and predictions. Questions because I believe, in some way, the most important product of knowledge is ignorance. And by that I don't mean, of course, the uninformed, stupid ignorance that leads to bigotry and racism and causes many problems, but informed, intelligent ignorance that allows us to ask good questions. Questions drive science. You see, the geometry of knowledge is something like this. Knowledge is a region in a sea of ignorance that where we've learned something about the natural world and we're always pushing outward into the sea of ignorance. But it's only on the periphery of the region that we know about where we can see the next set of questions. The questions arise on the boundary between knowledge and ignorance. So as we know more and more, we're aware of more ignorance and are able to ask new questions, and those are what drive science. So, because we've constructed this wonderful theory of elementary particles and the basic laws of nature, we're now able to ask wonderful questions that we weren't smart enough, didn't know enough to ask when I was a student. Some of these questions are questions, the ones I know about best are in physics and cosmology. The question for both cosmologists and physicists, as I said, is how did the universe begin? This is a serious scientific question now. Cosmologists really need to know something about what happened in the first billionth and billionth of a billionth of a billionth of a billionth of a second after the Big Bang. And maybe even what the Big Bang was. Could we possibly explain that? And what is the nature of the dark matter that we've learned constitutes most of matter in the universe? We can't see it, doesn't radiate, but it pulls on things gravitationally, so we know it's there. And we've also identified a dark energy, a vacuum energy that causes the universe to accelerate, and we don't understand its value and its, perhaps even its nature. And then we're striving to unify the forces of nature that we can describe very well. But they seem to come from one unified force. There are many such clues that point in that direction. One idea is string theory, that all the particles we see in nature are different vibrational modes of a single vibrating string. That's called string theory, which I've been working on for many years. Is that the answer? And I think in answering that myself, that we're now challenged to, once again, to revise our notions of space and time. So what is the true nature of space and time? And then in biology, there are wonderful, wonderful questions, working out the mechanism of the cell in great detail, but also asking, for example, how does consciousness arise from the collective behavior of neurons? And many, many more wonderful questions. And we have many of the instruments available to answer these questions. In the case of my field of particle physics, we have a large particle accelerator called the Large Hadron Collider, which is turning on this year in Geneva at CERN, and we hope will help us a lot in answering some of those questions. And in astronomy, of course, we have wonderful instruments we can now put into space to probe the universe and its past. So, I'll turn now to predictions. Always a dangerous game. Let me start with the near future, 50 to 100 years from now. Well, there I can predict with some confidence, I believe, that most of those questions that I asked, and many more, most of the questions of basic science that we ask today will be answered. That has been the lesson of the last few hundred years. Now, once questions are well formulated and become susceptible to observation, experiment, and speculation, they get answered within very short times. 50 to 100 years is a long time. So most of those questions will be answered. Maybe not how did the universe begin. That's, I don't know. But the others I have no doubt will be answered. But I also predict that we'll have new questions to ask, to ponder. Some of those new questions we can't formulate today because we don't know enough to be intelligently ignorant. I also believe that some of our the other disciplines, mostly those connected with human behavior, will move from infant science to real science. I think as we learn how the human mind works at the microscopic and genetic level, and we're beginning to, a long way to go, social science, political science, economics, all are areas which study human behavior, will have a microscopic theory on which to construct models and understanding and begin to be true sciences. As far as political developments go, I believe that we will be well on our way towards a sustainable economic and social arrangement, having dealt with our immediate problems and, I hope, a world government. But let me step back and make predictions over 100 to 1,000 years. Now you say, you laugh and say, well, 1,000 years, that's not such a long time. Our planet has been here for 5 billion years, life for 3 billion years, humans, Homo sapiens, for millions of years. What's 1,000 years? Nothing. And yet, to try to predict what will be in 1,000 years is truly impossible. We just have to go back 1,000 years and imagine someone from the year 1000 imagining today's world, today's science, today's technology. But it's fun to play that kind of game. And I'll give you 3 predictions of advances made mostly because of the growing control we have over life, biology, that I think are likely to happen over this period of time. And as you see, are the kind of advances that will have such great benefit that they're unstoppable, but also have grave dangers and pose problems to us as a species and to us as a culture. One will be the increased lifespan. I would imagine if in 200 years, without knowing too much about life itself, we've doubled the lifespan, that in the next 100 to 1,000 years, we will increase it at least by a factor of 10. Now that's quite a change, and one that we would all desire, and clearly, if we can do it, we'll do it. We can all live 10 lives. It makes a lot of sense. I think it's totally crazy that we take kids, young people, educate them for 30 years roughly, and then let them contribute to society for another 30 years only. After 30 years of investment, they have 30 years and then they retire. Well, we're pushing retirement to later, maybe 40 years. It's still much too short. It makes no sense at all. So this will happen. But it will pose enormous threats to the way we function as society. And well, you can imagine what the difficulties of dealing with a lifespan of 1,000 years would be. The other thing I think might very well happen is speciation. We are beginning to learn how to modify our genome. In the past, life evolved. Life always evolves, changes. Species go extinct. New species are created by random changes in our genome. That will continue. We're not going to stop evolution. But now we can direct evolution. We can speed up the process by directly causing mutations or causing changes that might cure diseases or improve some human characteristics. Or we will definitely, I think, be pushed to do that. And that will speed up evolution and might start over this very short period, this speciation, the creation of new species, so that 1,000 years from now we might look back and say that we are the missing link. But that, again, poses enormous problems and issues that we will have to solve. And the social issues that these two developments might create might be much harder to deal with than global warming. The third development that I think might very well begin in this period of 1,000 years is the spread of life throughout the galaxy. Another thing we observe in nature is that life spreads to any available niche that exists on our Earth. And eventually, once we're able to, we will start spreading throughout the galaxy. Now, we're not going to send spaceships with pioneers and colonizers. That makes no sense. But we might very well send microscopic, very small robots with lots of information on little microscopic hard disks, which can reconstruct life once they find a suitable place for it. And we will do that because that's what life does. Once we can do it, we will spread, and I don't think 1,000 years is too short of a time. So those are some ideas of really far out developments that might take place. And I challenge you to exercise your imagination and think what humankind will look like in 1,000 years, or if you're really brave, how about 10,000 years? Or 1,000,000 years, which is comparable to the lifespan of our species. One thing is clear, the exploration of science will continue to be even more important in tomorrow's world than it is today. It will continue to reveal more of nature's secrets and increase our control over its forces. And the consequences will inevitably both be good and bad. Hopefully, the culture of science will help us, inspire us to exploit the good and avoid the bad. Thank you.
So, wow. We can only respond with one word, and maybe we can borrow what the Mexican lady in Father Juan's story said. See. Anyway, let's give time for Dr. Gross to rest for a while. And let's give the hundreds of billion neurons in our brain time to formulate our intelligently ignorant, wonderful questions as we listen to a number from the USC choristers. I was told that they will perform a number entitled a hymn, which is the Cebuano term for that certain smile that supposedly is a subtle gesture of making somebody feel welcome and at ease. And that's probably what we all need at this time. So ladies and gentlemen, the USC choristers.
malungkot nga ikaw maluhod kanina. Kung wala'y bayo, ang kinabuhi sa tao wala'y pili. Sa mga bayo, manatagong ito kato, kahimong sa sikat tao, kalibutan, panyang pagkanindot mo, panyang pagkawanon mo, panyang pagkalingon mo, o pahiyo. Sa kalibutan, kapalitin, pahiyo. Hindi sa kagasan, labaw na magkagagaw, ano nang kinabuhi sa tao, magpalipayo. Ayong pagkainod mo, ayong pagkainod mo, ayong pagkainod mo, o payo.
Ako'y katapusan, manalasing sa pumasatanan. Pahiyo,
Payo.
kalulutan, kalibay sa
Talang tao, ikalimutan, pagkaindot mo, mahiyong pagkaluhanon mo, mahiyong pagkailun mo, o pahiyo. Pahiyo.
Thank you, ladies and gentlemen. US's Pride, the USA choristers. At this point, let us proceed to the dialogue with Professor David Jonathan Ross. May I request Professor David Ross to please come up stage again and please be seated at the center of the stage. Dr. Maria Victoria Carpio Bernido, Senior Researcher at the Research Center for Theoretical Physics at the Central Visayan Institute Foundation in Hagna Hall, will moderate.
Good afternoon, distinguished guests, ladies and gentlemen, and especially the young students, the young people in our audience. It is now our opportunity to learn and gain from the wisdom of our distinguished speaker by asking questions. We have been given 40 minutes for this dialogue session. To break the ice, perhaps I could raise the first question to Professor Gross. It is highly probable, Professor Gross, that you might have inspired many of the administrators, professors, and students in the audience. I will not be surprised if some of them might want to go to particle physics. But as a physicist myself, I have encountered the comment from other physicists from other countries. They ask this question: why are many third world physicists doing basic physics, basic science, like particle physics, while their country suffers in poverty? Could you comment on this, please?
Well, I don't, first of all, not many people do basic physics anyway. It's a very, basic science is not something that attracts that many people. But it is not something that any country can neglect, especially the underdeveloped. I sometimes compare science to a tree. So, you know, a healthy tree bears fruit. And the fruit is wonderful. We like to eat the fruit. It tastes good. But that tree cannot survive without a healthy trunk and a healthy roots. Basic science is sort of the roots and the trunk of the tree of science. The fruits are just dangling from the branches. You don't get good applied science and technology unless you have basic science. Now you might say that in an underdeveloped country you don't need to do basic science because somebody else will do that. Like in the United States or Europe. We can just steal those ideas. We don't have to steal them. They're made available to everyone. And all we have to do is concentrate on application. Well, that doesn't work either. That process was tried in China for many years. And they realized after a while that somehow they weren't attracting the best people to science. Or if they were attracted to science, they weren't attracted to science in China. And that furthermore, the people who were going into science in China weren't getting the best education. And their technology applied science had no chance of becoming first rate without the roots and the trunk of basic science. So as a national policy, they shifted completely, and I've been in fact helping the Chinese in their desire to become a leader in basic science, in producing new ideas in the 21st century, and they will. And that will drive their technology. I've never seen any place in the world where technology is first rate without having the foundation of basic sciences. That's what attracts the young people, I'm sure. If we had a poll of the young people, the reason they go into science is because they want to understand some of these big questions of the type that I formulated. Now, when they go into science, they learn that science is more than just that, those kinds of big questions. There are many other smaller questions and more applied questions which are absolutely fascinating and to which they can make great contributions. But they're not going to be attracted to science unless that is going on in their countries and their universities. And they're not going to have the right instruction, the right teachers. They're not going to have the foundations on which modern engineering, modern applied science can be built unless that basic research and basic science goes on in their institutions. So I think it's a very short-sighted policy just to imagine that any country can ignore basic science and basic research and just live off other places in the world. And it's not expensive. It's not that expensive either.
Thank you. That was very encouraging for us. So, yes, the gentleman in the other perhaps we should wait for a microphone. There's a microphone there.
Professor Gross, from your presentation, it's quite clear that the world cannot continue to depend on fossil fuel for various reasons. So my question is, what keeps nuclear fusion technology from being realized? What are the biggest barriers for it to be accomplished?
Fusion. Well, fusion, is a very hard problem which is at this point almost an engineering problem. I mean, people have succeeded in fusing nuclei as happens in the sun or in thermonuclear H bombs, but also in tokamaks and fusion machines to produce energy. But to turn that demonstration into a working factory that produces energy in a way that is economically viable is a major engineering, essentially, task, and one that the world is trying to solve, but will take many years. There's no particular barrier that makes it impossible. It's just a lot of hard work and clever innovations. I would like to get some, we've had questions from two of the senior scientists. I'd like to get questions from young people. I mean, remember, it is a big mistake in life to be shy, especially in science.
Yes, please.
Vincent Istes from Springfield School, science teacher by profession, world history teacher by choice. What struck me the most during the lecture was on the issue on world government. I'd just like to ask Professor Gross if he doesn't think that the existing treaties and international agreements that we have are enough to create these working conditions where the world could focus on the problems that are facing us as a whole, as a planet. Because in the first place, if we come up with this world government, there are a lot more problems that this world government would create. Instead of solving these problems that it wants to solve, it would create more problems. For instance, the case of dismantling armed forces around the world, which should be logically the first step of a world government. That I think that is the most difficult task that a world government would have to face, and it's near impossible. Thank you, sir.
Well, you're pointing to all of, I mean, you're correct that if you try to imagine a world government, indeed, you would have to solve or ameliorate many problems along the way, such as vast inequalities in economic standards around the world, such as, national armies, and so on and so on. You're just explaining, in fact, why it's so important to have a goal like that. Because to achieve it, you're going to have to solve all these other problems which we should solve anyway. So think back, for a European in 1940, 39, to imagine that by now, all of Europe, including Lithuania and Serbia and Spain and England and Germany and France and Italy, would be united in a union which has a common currency and growing disappearance of borders, and is just unimaginable. And if somebody like Einstein had suggested, as he did, advocated world government or European government, he would have been laughed at. He was laughed at. All such people were laughed at. Nobody imagined that such a thing was possible. So that's an example of how, in order to achieve the European Union the way it is now, many things had to be done. And they're still far from being a single entity. Other barriers will disappear over the years. But a lot of those problems were gradually solved, but they had a goal. I'm just suggesting that eventually we're going to get there. If you ask how that's going to happen, I can amplify my prediction. We are moving towards larger entities. The European Union is becoming a very large country. We have other large countries. If the United States and its neighbors might eventually become a kind of union as well. So one way of getting towards world government might very well be that we will end up with 5 large entities which comprise most of the world's population, 5 or 6, and then they join. So you join in stages. But eventually this will happen. It makes no sense to have this kind of divisions and I know Filipinos are very nationalistic, but to some extent nationalism, I think, is the biggest enemy of peace and progress. And it is silly. Much of it is silly, doesn't make sense, and serves little purpose except to help politicians stay in office. So eventually it will go. Along the way to get there, we'll have to solve many other problems. You're right.
I think the student there at the back was raised early.
Good afternoon, Professor Gross. Sorry, I have a cold. Anyway, I'm fourth year applied physics students in this school, so I have got a lot of questions, but then I only had the sensibility to write one of them down. So yeah, here's my question. Now you talked earlier about the greatest product of knowledge is ignorance. Now, it's kind of intimidating to be in a person such as yours. Now, don't you think the kind of control that science is trying to think is only an illusion? I mean, the more knowledgeable we become, it seems that the more ignorant we become to that higher level of knowledge. That's my question about science and control.
Well, it's not. Yes, so I tried to explain to you, in fact, why both things can coexist. Knowledge increases. There's no question about that. Just go look at the libraries. Knowledge increases rapidly. So does ignorance. We have more questions nowadays, and we do have this feeling that the more we know, the more questions we have. So ignorance also increases. That's evident because knowledge is this sort of region in the sea of ignorance that's moving out. So knowledge is increasing like the volume of the region of knowledge. And ignorance is what we can see on the How can wisdom increase if ignorance increases? Well, it's because knowledge increases faster than ignorance. Knowledge increases like the volume. And ignorance increases like the surface area. And the surface area increases slower than the volume, as you know. So wisdom also increases. So it's perfectly possible to have this situation which we're all, certainly as scientists, aware of. That we know a lot more. Every year I look back a year ago. God, we were stupid a year ago. We know so much more now. But I have new questions I can ask. And yet I feel a little bit wiser.
would you accept a written question, Professor?
Sure.
Yeah. There's a young lady here, she must have been too shy. What in your life influenced you to be passionate about physics, atoms, and all these elementary particles? This is from Cherry, a sociologist from UP, Cebu, University of the Philippines.
Well, atoms are really fun things. I got interested in physics as a child, when I was about 13 or 14, just by reading popular science. I didn't know that much, so but I read wonderful books by Eddington and Gamow and people like that, explaining what the great discoveries past and ongoing in atomic physics, astronomy. It was very exciting. I just found it enormously interesting. And I found the challenge of trying to learn more about nature, especially learning by theoretical physics, by using one's brain, and with mathematics, which I love, just to be awfully challenging. I like puzzles. This is the biggest puzzle in the universe. And it's a lot of fun to solve puzzles. And they're not just puzzles that someone makes up. This is nature itself. So it's a very exciting, and most of my friends, scientists are not a nerdy, dispassionate, boring set of people. They're very passionate people. They love what they're doing. They work, 12 hours a day, 7 days a week because they love it. It's an adventure. I highly recommend it to you all.
Yes, please. You'll be next. You'll be next.
Good afternoon, Dr. Cross and everybody. I'm Mr. Noel Satyambre, physics teacher from Southwestern University, ping pong athlete and enthusiast. I am actually too shy to do this, but I have to overcome it because it's a privilege, a once in a lifetime opportunity to talk to a Nobel Prize winner in physics. Dr. Cross, I'm teaching physics, basic physics, and I've noticed that in the curriculum, we can usually teach only a small portion, especially mechanics portion, thermodynamics, maybe light. But most of the important topics in modern physics are seldom being taught. It's because maybe of the short period of teaching. What do you suggest to improve our teaching?
It's a very good question. Physics has a tradition of teaching following the historic evolution. So we start with mechanics and heat and electricity and so on and so on. We only get to the exciting frontiers in graduate school. There might be other ways of teaching. I doubt it. It is that historical evolution that physicists learn that develops intuition and also builds up 400 years of knowledge. Now we do it very efficiently so that by the time after some number of years people can already learn all those 400 years of knowledge. We understand it better and better so we can teach it better and better. But it's very hard to start directly with quantum mechanics. Now, it is possible to give a survey, a broad stroked description of modern science, and that's probably worthwhile adding on as an extra, and even at the beginning, to turn students on. But the other alternative is to give them, at the same time you're building up the knowledge of physics, just tell them about or direct them towards the many resources that exist in popular science. That's how I got interested. I mean, when I was 13, I started reading books about Einstein's discoveries. I didn't even know mechanics. And I was motivated to go learn mechanics, go back. But I could read these popular books that told me about science at the frontiers, and that's what got me excited. And it's not just books nowadays, it's the internet. I mean, on the internet there's so much material. So if you direct the students who are interested, or give them some exposure to books and to internet, they can do that on their own, independently of the methodical learning of physics and mathematics. Neat.
Okay, shall we have the next question?
Hi, David. I'm unlike you. I'm related to the solar system. I'm a planetary astronomer. But I have a question with regards to the updates on the unification of gravity to the three forces of nature. I was wondering what updates you have, or are we getting closer to unify gravity to the other three forces of nature?
Well, we are more and more convinced that that's the next real big step that we have to take. All the clues point towards a unification of the atomic and nuclear forces together with gravity at a very short distance scale. String theory, which I work on, does that. It does unify all the forces together and all the matter together. But it's a very complicated and mysterious theory that we don't truly understand yet. So whether that is really the right road, I think so. But whether it really is, or whether something is seriously missing, we don't know. So this is one of the main, in fundamental physics, this is one of the main goals that we have. And, we're getting closer, but by little steps. And probably a few big steps will be still needed.
Before we proceed to the next question, the gentleman who just asked the question is Christopher Go, who is a physics alumnus of this university, and he was awarded the San Carlos Borromeo Medal for his discovery of Jupiter's red spot. Junior. Yes, please.
I'm Nick Buetcotsejo, the Dean of the College of Engineering at this university. I have so many questions, but when I first came, I was expecting you will be presenting the string theory. Then I was also expecting you will be predicting when to unify all those theories and how many string theories are there now. Then, but anyway, you raised a very nice presentation, especially on the issue of your predictions and also on the idea of a world government. So while you were presenting, and then one of the prediction was in 100 to 1,000 years, we should be able to understand emotions from microscopic or maybe from physical point of view. Then I relate that with world government, and maybe by that time we can also have a society where we can more or less have a predictable, or we can predict the emotions of the population, something like that. But then I ask myself, is that okay? Then I look back at your lecture and I found out you never mentioned the issue of ethics. Ethics. And those other aspects which are not pure science, but which has something, which has a very great impact on humanity, on how we as a group or under one single government, world government, will behave. So I was wondering whether the predictions were right. I think I would predict the same. But what I cannot see is the humankind as a whole, with science with them, and at the same time the issues of religion, ethics, and so on, and the world government.
Well, partly I didn't talk about that because ethics is not in my realm of expertise. But I think as you say, I implied that as we learn more about the human mind and about human behavior, those human sciences like sociology and political science and psychology will become real sciences and have real applications. And that can be good and bad, which is an ethical question as well. We can imagine taking advantage of that knowledge to solve some of our problems that we encounter in our interaction, one human with another, promote peace. But we can also imagine using that knowledge to control other humans. So all knowledge has these two edges, two things, good and bad, can be used in different ways. And the only guidepost, among the rest, is our ethical and moral considerations. And it is very important for us to take those into account. I think the biggest challenges that will require that kind of judgment in the next 100 years are likely to be as consequences of our increased understanding of life, which will lead to things like, as I said, some of my predictions on lifespan and speciation, but also on the control, on the understanding of human behavior, and human emotion, and human consciousness. So we're going to have to, continue to exercise judgment and value and insert values into whether we make good or bad use of this knowledge. But that is sort of, as I said, outside my expertise.
This is another written question. It touches on ethical questions. This comes from a nursing student of University of San Carlos. Do you agree, Professor Gross, that mutation is one of nature's ways of evolution? If so, these days we have been trying to battle genetic mutations in humans. Do we have the right to slow down or even stop genetic mutations?
Well, we can't actually slow down genetic mutations. They occur, I had a colleague, a physicist colleague of mine in Princeton, Eugene Wigner, also won the Nobel Prize, prize in physics. He wrote an article before DNA was discovered, wrote an article which he proved that ordinary physical or chemical processes could not explain life that reproduced itself because mistakes would accumulate too rapidly. Just based on random physical events. You are being bombarded all the time by cosmic rays. There are muons passing through you, thousands of them every second. Now you don't feel them because most of them don't hit any of your nuclei and cause any trouble, but some of them do. That's why if we send astronauts to the Mars, they would come back dead, unless we surround them by lead shields, just these cosmic rays. most of them don't get through the atmosphere, but they get through and they hit you, and every once in a while they hit a molecule in your DNA and they cause mutations. That alone causes too many mutations. So much so that Wigner concluded that we'd really be in trouble. What he didn't take into account was the fact that, as a molecular biologist discovered, was that there is a mechanism in the cell that goes around and corrects the mistakes, the mutations that occur most of the time. So that the mutation rate is reduced by 3 orders of magnitude by this continual effort of the human cell at the DNA level to correct the mutations. So we've developed this mechanism, and we cannot, I think, perfect it any better than that. And so the mutation rate is small, but enough to cause variations that lead to revolution. What I was talking about was what we haven't yet begun to do, and that is cause, not mutations, which we can easily cause if we wanted to by, X-ray machines, radiation, but rather just based on our specific understanding, go into the genome and correct mistakes, which can eliminate autism and schizophrenia and other diseases which are now believed to be genetically controlled. And we are clearly going to do that. If we identify the cause of schizophrenia or autism in the gene, I'm sure you'll agree upon thought that humankind will do that. But we will also perhaps be able to do not just eliminate disease, but also correct, or improve the genome. Imagine that your parents had the choice of improving your genome so that you would be taller or smarter. How many parents, especially in Asia, would not be willing to improve their children's genome so they would have an increase of 20 points in their IQ? I think many would. This inevitably will happen. How many people would not go along with changing the genome so that aging will be delayed by a few hundred years? I think it will be hard to stop that. That's what I think will lead eventually to this speciation, to our evolving into, under our directed influence, to different species.
We have time for 2 questions. Yes, the lady, yes, please. The activity we have now bridges us towards a culture of peace. Now, can we not also have bridges towards the development of the culture of science? So that maybe, hopefully, in 50 years from now, we will have a Nobel laureate of physics as a Filipino. So, Professor, what would you advise to inspire our young people here towards the development of a culture of science, side by side, the culture of peace?
I think I applaud such a development. I think the burden is not on the young people, but the older people. The young people, when I travel around the world, young people everywhere are fascinated with this. And that often gets destroyed someplace in school, and if not in school, by the lack of opportunity. So it's up to the old people to provide, not to dampen the enthusiasm that children naturally have about the exploration of nature, but provide, not to dampen that enthusiasm, and to provide opportunities. And of course, what will happen, I mean, there are many brilliant Filipinos, many of them, however, have left the Philippines because this society hasn't yet provided them with all those opportunities here. And Philippines, has no reason why it can't. I don't see any inherent reason why it couldn't. It's not a small country. It's 90 million people, larger than many countries which were as much poorer only 50 years ago and are now major scientific centers like Korea. So there's no reason why it couldn't happen. The young people should demand it. The old people should provide it. It's good for the Philippines. It's good for you all. And it shouldn't take 50 years. Science can develop overnight. A scientific generation is only 5 years. Take a student out of college, train them to be a researcher. They then start training students in about 5 years. It's 5 to 10 years is a scientific generation. In 50 years, you can have 6 or 7 generations. So there are countries that have evolved rapidly to become major scientific centers in much less than 50 years.
Thank you. Yes.
Afternoon, Dr. Gross. I'm an MS Physics student, and I hope to be working on my thesis, and I was hoping that you would help me with my thesis. Okay, seriously, here's my question. If you eventually achieve your goal of unifying all the forces and come up with a theory of everything, what do you think would probably be its most important consequence?
More understanding and new questions. Knowledge that really is, I want to understand some of these questions I work so hard to try to figure out. I really want to know the answer. Then, there are new questions I'm sure that will arise that we don't know about today. So both. Now, real big advances in science have impacts outside the own area in which they're working. For example, a lot of the advances we've made in particle physics, the standard model have had enormous impact on our understanding of the history of the universe. Because that is what governs the early history of the universe, the physics of what goes on inside nuclei, and even at smaller distances. So, the importance of, in particular, coming up with this unified theory which we truly understand will, I hope, allow us to go back even farther and understand the very early history.
Unfortunately, we have to end this session. Very interesting. Let us thank Professor Gross for his
So thank you, Dr. Benito, Professor Gross. We now move on to the awarding ceremonies. May we request Professor Gross to please stand at the center of the stage for the presentation of the San Carlos Borromeo Awards. Father Roderick C. Salazar Jr., SVD, will now present the San Carlos Borromeo Award to Professor David Jonathan Gross. Father President will be assisted by Father Teodoro Capus, SVD, Vice President for Academic Affairs, and Father Dionisio Miranda, SVD, Vice Chair, USC Board of Trustees, as well as Presidential Assistant for Planning and Development. Father Salazar will now read the citation.
once again, ladies and gentlemen, I suppose you agree with me that this has been a very enlightening afternoon, and we are very grateful for the presence of Dr. Gross, the party, and your presence here. What Professor Gross has done was to make basic physics principle reachable, understandable, at the same time that he challenged us to go beyond what we will have understood. And we are indeed very grateful for that. So in gratitude for what he has done here, and in recognition of all that he has done in his profession, we should like to present to him two things. One, the commemorative history of the University of San Carlos, and on top of that, an award that we call San Carlos Borromeo Award. Our university is named after San Carlos Borromeo. The reason for our being named after him, was that in his lifetime, Carlos Borromeo, who became a saint, insisted that all the seminaries, all the future priests should have a formal course of study. That is why many seminaries in the world are called after San Carlos, or in English, as you know, St. Charles. We insist that we be called University of San Carlos. And because he personified what is now in our logo, Scientia, Virtus, Devotio, we have said that in gratitude for this great event, of which we are participants today, it is only right that we award our distinguished speaker with the San Carlos Borromeo Award. And so, University of San Carlos here in Cebu City, Philippines, presents this San Carlos Borromeo Award to Professor David Jonathan Gross, 2004 Nobel Laureate for Physics, for exemplifying in his life and work the ideals of Scientia, Virtus, Devotio, of our patron and of our university. Given on this 11th day of January in the year of our Lord 2008 at the University of San Carlos. On behalf of the whole university, I sign this San Carlos Borromeo Award. Congratulations and thank you, Dr. Gross. Before we let Dr. Gross and company leave the stage, we must equally honor and thank the person who brought this event to our shores. This past year, in the Catholic Educational Association of the Philippines and in the University of San Carlos, we had a national convention and university days under the theme Beyond Borders, Within Worlds. What has happened is that the Bridges program, initiated by our awardee tonight, had gone beyond the borders of Asia, of Thailand, come to the Philippines. And it is because of this that we are gathered here. So our way of saying thank you, Uwe Moravitz, please come to the stage for the commemorative history of the University of San Carlos.
So once again, thank you and congratulations to 2004 Nobel laureate for physics, Professor David Jonathan Gross, and of course also to Dr. Uwe Moravec. Thank you very much. Ladies and gentlemen, let us now pay tribute to our alma mater, the University of San Carlos, by joining the USC choristers in singing the university hymn. And please remain standing after that for the recessional. The order of the recessional begins with Father Roderick C. Salazar Jr., SPD, followed by Professor David Jonathan Ross, Dr. Uwe Moravec, the University Board of Trustees, and the University Cabinet. During the recessional, may we request the audience to please remain inside the theater until the entourage has completely left. After that, the USC faculty and students are requested to leave the theater through exit A, and the VIPs and the guests, please take exit B. So ladies and gentlemen, the USC hymn.